Hello, everyone. My name is Nima Kaviani, and I'm a solutions architect with AWS. I'm here with my colleague, Manabu McCloskey, and we're going to talk about improving visibility and traceability of deployed container artifacts via Spinnaker's CiBuild. All right, so to start, CI/CD is about enhanced productivity, right? And DevOps engineers want from their CI/CD system is to have a system that actually allows them to have control over the rollout of their software system. They want the process to be repeatable, and they want to have visibility and traceability in order to understand what's happening with the rollout of their software. And in case of failure, they can go back and figure out what's wrong. Now, if you look at the State of DevOps report for 2020 that came out, the majority of the work that the DevOps engineering teams do, regardless of the size and the state of the evolution that they're in, is around automating workflows and processes, building a specific self-service tools for their team so that they can better be able to track, the rollout process of their software system, and also create interfaces and integrations between different systems that they have in place so that they can improve visibility and traceability, right? So I don't know about you, but one of the bigger challenges that I had when I was constantly rolling out software to the infrastructure was that, every now and then something in the delivery pipeline would go red, and I had to go figure out what the problem was. And especially for software systems that follow microservices architecture, there are a lot of moving pieces, right? So really nailing down what the problem is and what's causing the failure is quite difficult. In an ideal world, what we want is, your system is actually designed in such a way that you can quickly identify the component at fault, and then you can identify and trace back the failure to the changes that are made to the code, and then fix those changes and reinitiate a new rollout of your software system, right? Pretty easy. So for Spinnaker traditionally did not integrate with build tools, right? So for developers and for engineers to figure out what's wrong with the deployment of their software system, they had to go back and forth between the build tools and Spinnaker, and it would result in a lower productivity of these engineering teams. It would slow down progress, and it was error prone because you would lose track of things. So what CiBuild aims to do is actually to solve the problem. It aims at integrating build systems with a Spinnaker so that you can have a one-stop shop for tracking everything from the creation and build of your software system all the way through the rollout and deployment of the software system. The way Spinnaker actually takes care of software deployment is that it monitors your software artifacts, let's say your software containers, and by looking basically at the registry and querying the registry for changes in your software artifacts. And the moment it actually notices a change in, let's say, the tag that your container has, it actually picks up that new container version and deploys it to the cluster, right? But if it happens that along the process, the container actually is bad, right? And something fails part of the deployment of the container. If you go back to Spinnaker and ask, okay, what went wrong? Spinnaker probably cannot help you, right? And that is the problem. That's the lack of visibility that we've had for so long in Spinnaker. So what CiBuild tries to solve, or the integration with the build system tries to solve, is that it connects Spinnaker with the source control system, with the build system, and with the artifact registry in such a way that you can reason about failures and the version of the software that gets deployed. So in this case, if it happens that there's a failure in the system, you can go back to Spinnaker and ask, okay, what's failing? And then it has enough integration with everything else that it can eventually point you back to the piece of code that is resulting in the failure. So CiBuild at this point integrates with Jenkins and with GitHub. And this is something that we plan to extend to other build systems and to other source control management systems. So let's talk about the integration and the open source collaboration that resulted in this integration. All right. So the CI build integration is something that Netflix already had internally. Basically, Netflix has something called a CI wrapper that sits in between a Spinnaker and their source control system and their build system, which I believe is Jenkins. And when it happens that a Spinnaker wants to roll out a new software artifact, it can go to that CI wrapper and query the CI wrapper for the information about that software artifact. And then the CI wrapper has enough information to go to the build tool and to the source control system and collect information about build details, build logs, etc., and also the commit ID from source code, and put everything together and report it back to Spinnaker so that that correlation can happen. And what we wanted to do in the integration work that we did as part of the open source collaboration was that we wanted to utilize efforts from Netflix delivery engineering team in basically reusing what they've already built into Spinnaker, but also enable it so that it doesn't require the CI wrapper that Netflix is using internally. We wanted to extend the Spinnaker for the feature to be available. We did not want to introduce a new component into Spinnaker. We wanted to leverage the existing set of components that the Spinnaker already has. And we wanted to be able to bring together eventually source data, build data, and deployment data. So there are two parts to integrating build information into Spinnaker. One is showing build information to the end users, right? So what happens when you actually install this new integration plugin that we built to your Spinnaker deployment is that in your Spinnaker environment, you get a builds tab. And once you navigate to that builds tab, it actually brings in all the build information from your build tool, in this case, Jenkins, into your Spinnaker, so you can actually look at everything right there. You can look at the commit version that has resulted in starting the build. You can identify the job number in your build system, and you can look at build logs, you can look at the generated artifact, etc. And then there's also links to the source control system and to your build system if you choose to go to those systems and track them more closely. So for this to happen, what we decided to do, and here I assume that you kind of understand the lower level components of the Spinnaker. So Igor, which is the component responsible for integration with source control systems and also with artifact registries, we enhanced Igor in such a way that it actually queries Jenkins for build information and collects the commit information as well as the job ID of a given build from Jenkins. Then with the commit information and with the information about where the source code for the software artifact lives, it actually queries the source control system. In this case, the integration has been done with GitHub. So it queries GitHub for commit information of the particular commit that has caused the creation of the software artifact. And then it collects all that information and makes them available through Gate to the Spinnaker users. So when users go to Deck and click on the build tab that I just showed you, Gate navigates that request to Igor. That information is pulled from these external sources, is put together, and is reported back to the user. So that's what they see when they go and visit the build tab. Now, there's another part to it, right? Because build information is cool, but most of build information you can already get by going to your build system, right? And the one benefit that build information integration in a Spinnaker does is that you have one stop for everything. But more importantly, you want to actually be able to track back the artifacts that you create to the sources of creation of those artifacts. So this is where the integration with the rollout system comes to play. For managed delivery, if you're familiar with managed delivery, it's the GitOps take that Spinnaker has for rolling out software. And so Build CI integrates very nicely with managed delivery. And if you go to a given version of an artifact, you see that it provides information about the author, the commit information, and also the branch and the repository, right? And you can always click on the commit information and it actually takes you to the source control system and shows you for the set of changes. So this integration was a little bit harder to be provided in the build plugin that we built. The way it's done is when Jenkins create the container artifact from the source code, it actually adds some metadata into that artifact by actually labeling the artifact with some extra information that relates to the commit ID that software artifact is actually built from, build number, the name of the job from your build system. And once all of that labeling is done, it then uploads that artifact to the container registry. So the new version of the artifact actually triggers identification of changes in Cloud Driver, which is the component responsible for consistently checking and to see whether or not there is a new version of artifact available in the container registry or artifact registry. And when Cloud Driver notices changes, and then it pulls information about container registry, but with the plugin, you can enhance Cloud Driver in such a way that you can tell Cloud Driver to also inspect the container artifact for extra metadata information. In this case, the commit ID and the build number and the job name. And so Cloud Driver gets that information and returns that information to Igor, which, as I mentioned, is responsible for tracking changes in software artifacts. And then when it happens that the user queries for that information from managed delivery, that information is already made available to managed delivery through Igor, and then managed delivery and its microservice Keel are then able to return that information back to the user, so that the user can exactly see what changes have been made. So that actually is a quick rundown of what the plugin does and how it integrates with the different microservices in a Spinnaker. As I mentioned, in order for us to be able to do this, we had to modify Igor, we had to modify Cloud Driver, we had to modify Keel, and then we had to add this extra plugin that kind of takes care of collecting the information from all these external services and putting them together so that they can be used by end users. So with that, I'm going to hand it over to Manabu, who's going to show you a demo of how this works.
All right, thanks, Nima. My name is Manabu McCloskey. I am a solutions architect at Amazon Web Services, and I work closely with Nima. So just for this demo, I have a Jenkins server running within my Kubernetes cluster. And I also have a demo application that's running in another cluster. It's this just part. And if I were to go to the Jenkins server here, you can see that I have this pipeline defined. This is just going to be building the Docker images for us. And if I were to look at the this GitHub repository, this is the repository that Jenkins is going to build Docker image off of. Within here, I have a Jenkins file. This Jenkins file just defines the job that Jenkins is going to do it for us. Since we're doing the Docker build within the Docker, now I'm just using a Docker in Docker image here, and it's just very simple. I'm just cloning a repository, and then we'll be just building the image using the Docker command, and then finally we'll just be pushing that to the this particular repository we have. Okay. And if I were to go to this front-end index.html file, currently it just says hello world, but I'm just going to change it to something so we can see the changes that we are going to be taking. So change to hello world number 2. Then I'm just going to commit this change. And this is going to kick off job by Jenkins. Oh, there you go. So you can see number 12 was just kicked off right here. Then you can do all the Jenkins stuff. You can look at console log, what changed and whatnot, right? But what is actually more interesting is if I were to go to my Spinnaker instance here, and then go to my application, which is just LED demo. And if I were to go to the build tab here, you're going to be able to see this build that was just kicked off. So this is build number 12, corresponds to this build that we were just looking at. And you can also see the past build like so here as well. So you can see what code changes led to this particular build. If you click on this, you can see changes that's made, the whole bunch of changes here, as well as who made the change and the message that's associated with it. And finally, you can click on this to see what job, the actual job within Jenkins. And finally, you can actually see the artifact that was generated as a result of this build. In this case, you have one artifact, which is just the this particular Docker image. And as you can see, build number 12 just passed, and you can see what happened during the build, like as you expect. And if I were to move to the environments tab on the left, you can see that managed delivery is now deploying this new artifact. In this case, it is just the Docker image that was just built. And if I were to do a port forward, and if I were to go to localhost 8080, you'll see that the change that we just made. So yeah, this was just a quick demo of showcasing what's possible through the build plugin, as well as like a little bit of the managed delivery as well. Okay, so what is next for this plugin, right? So there are a few things we would like to do with this plugin. First, we would like to add support for more build systems. As you may have noticed, we only support Jenkins as build systems at this moment. Although Jenkins is still a popular CI system, there are other popular CI systems out there. So we would like to support other CI systems like GitHub Actions or AWS Code Commit. And second, we would like to add support for more source control systems. Currently, we only support GitHub, but we would like to extend that to other systems like GitLab and Code Commit. And third, as we add more features to the plugin, we would love to see more adoption in the Spinnaker community. Being able to see and track down code changes from Spinnaker is a very nice feature, and it will enhance productivity for end users as well. And lastly, we would like to donate this to the Spinnaker plugin repository in the future. We are not sure when yet, but this is something we would like to do in the future. And finally, this plugin is all open source, and we would love to have you join us to make this plugin better. We realize we are not supporting all the CI systems that you might be using. So if you have any ideas to do with this plugin, just please let us know, and we will see what we can do. Thank you very much for attending this talk, and if you have any questions, please let us know. Thank you again.
All right. Thank you very much, folks, for joining. And this is live now, so hopefully things go okay. Manabu is planning to join me as well. But if you have any questions, oh, here he is. Hi, Manabu.
Hey.
If you have any questions, if you have any thoughts, please feel free to ask. I'm monitoring Q&A and chat. I think the important message here is that we are doing a lot of open source work for the Spinnaker community here at AWS. And the CiBuild integration and the managed delivery plugin are two of them that are available to the community. I know some of you in the audience have already experimented with the managed delivery plugin, which is like, as I mentioned during the talk, it's the GitOps C twist to Spinnaker, which we're super excited about. If you were at the SIG meeting yesterday by my good friends Luis and Fletch from Netflix, they told you that they've doubled the use of or the deployment of their software within Netflix using managed delivery. So this is like a fast-moving part of a Spinnaker. Join the SIG channel and talk to us about things that you want to see implemented in Spinnaker's managed delivery. And the build CI integrates very nicely with managed delivery, allows you to actually integrate very easily your build progresses into your managed delivery deployments. So if you can drop the GitHub links into chat, yeah, for sure. So there is one for CiBuild. These are under my personal GitHub account, but soon, as Manabu mentioned, we are going to donate them to the Spinnaker repo. That's definitely coming. We just wanted to make sure that it doesn't have like too many bugs when we shift things over, but this will definitely happen. And yeah, I think that's all I've got. Manabu, you have anything to add?
I don't think so, but we are looking for feedbacks and features we would like to add. So if you have like any features or questions about using that, just please just let us know. Just open an issue in GitHub, or you can find us in the Spinnaker Slack as well.
Yeah. Did you find the? Okay, awesome.
Yeah, I'm typing in
this is the managed delivery one. So these two are the open source plugins that we're working on right now. We're doing a lot of work with Netflix on improving Keel and improving other Spinnaker microservices, as I mentioned. So, and it's all open source. So if you're interested, please join. We are an open community, and we are nice people, I hope. All right. If there's no other question, thanks again for joining. Looking forward to talking to you more on the SIG. Have a good rest of the day and everyone. Bye.
Thanks, guys.